Hello everyone, today we will do the same integral as the previous video, however in a new method and easier method. I got it from BlackPenRedPen. Check his channel in the description below. Okay, let's get started, but before doing the main integral, I will do another integral just to get the idea of the whole idea of this solution. Let's name it g. This g will be equal to the integral of x to the power of 2 plus or minus 1 over x to the power of 4 plus 1 dx. Alright, we divide everybody by x squared, so we get 1 minus 1 over x squared, yeah, and here x squared plus 1 over x squared, here dx. Now we can complete the square for the denominator. We have px, let's name it px1, p1 px will be equal to x squared plus 1 over x squared. And to complete the square for it, let's write x squared here, and here 1 over x r squared, and here plus or minus, let's put them plus, okay, plus 2. Here's 2. This multiplied by this, so it's x multiplied by 1 over x, which is same as 2. So let's just subtract 2. So this reserves the same value of p1 for x. Okay, so p1 for x will be equal to the parentheses x. Let me write it in red. We have parentheses x plus 1 over x all squared minus 2. Let's put this here. Yeah, like it. We have g equals the integral of this remains the same, and this becomes okay, the x. This becomes x plus 1 over x all squared minus 2. Alright, now we see that x plus 1 over x, its derivative is the same as 1 minus 1 over x squared. So let's use a substitution. Let's let u equals 1 plus 1 over x, so that du will be equal to 1 plus minus 1 over x squared r multiplied by dx, so that g will equal to the integral of this part will be the same as this 1 minus 1 over x squared dx will be du. Okay, so du over this part squared, so u squared minus 2. Alright, we can factor the denominator. We get the integral of du over u minus 2 multiplied by u plus 2 with square root of 2, and here square root of 2. Okay, so that g will equal to something a, let's name it a, du over u minus square root of 2 plus integral of du over u plus square root of 2. And here the b, I forgot it. We put this to be equal 0, this to be equal 0, and hide it, so that u equals square root of 2, put it here, so you have 1 over 2 square root of 2, so that a will be equal to 1 over 2 square root of 2, which is same as square root of 2 over 4. And b, by the multiplying method, the numerator and denominator by square root of 2. So okay, so we do the same thing here for b. put this to be equal 0, so that u equals minus square of root of 2. Hide it, put this minus square root of 2 here, so you get minus 1 over, sorry for the pen, minus 1 over 2 square root of 2 equals same as this, but minus. Okay, let's continue. So that we name it g equals the integral. Wait, before writing the integral, we write the coefficients because they are just constants. Du over u minus square root of 2, yeah, plus square root of 2 over 4, here minus, okay, integral of du over u plus square root of 2. Okay, here, I guess we are done. G equals square root of 2 over 4. Let's take it as common term. This part will be natural log of u minus square root of 2. And this part will be minus square root of 2 of u plus square root of 2. Okay. Oh, wait. This part will be, yeah. Let's use the brackets here. Plus c. So that g equals square root of 2 over 4 natural log of this part over this part, which is u minus square root of 2 over u plus square root of 2. We know that u is the same as x plus 1 over x. Let's write it down. G equals square root of 2 over 4 natural log of x plus 1 over x minus square root of 2, and here x plus 1 over x plus square root of 2 plus c. Let's multiply the numerator and denominator by square root by x. Okay, so we get g equals square root of 2 over 4 natural log this squared. This will be plus 1. This will be minus square root of 2x all over x squared plus square root of 2x plus 1 plus c. This is the answer. Let's write it here because we will need it. Alright, we finished this g, and now let's move towards the I, which is original integral. It's the integral of dx over x to the power of 4 plus 1. This integral is it's very different than this, but we can make it the same as this. How? Let's put for the integral of x squared minus 1 x to the power of 4 plus 1 dx, and this is no longer the same as the original. So let's subtract and x, okay, x to the power of 4 plus 1, but we need a 1 in this place, so let's put minus 1, but minus 1 minus minus 1 is just 0, so this whole thing is just 0. We kill the integral. So instead of doing minus 1, I will do plus 1 and see what will happen. Okay, dx. So let's check. X squared minus x squared is 0. Minus 1 is minus 2. Okay, so let's put minus 2 here. Yeah, minus 1 over 2. Okay, so that we preserve the same value of this integral. Okay, so I will be equal to minus 1 over 2 integral of this is just g. So we can say brackets, yeah, use the brackets, here g minus an integral which is integral of x squared plus 1 over x to the power of 4 plus 1 dx. Let's name this integral as h. So I equals 1 minus 1 over 2 g minus h. and compute the h. H will be the integral of x to the power of 2 plus 1 over x to the power of 4 plus 1 dx. First, what we will do is to complete the square, but before that, we have to divide everything by x squared. So h equals the integral of 1 plus 1 over x squared, and here x squared plus 1 over x squared dx. Alright. What we will need is something x minus 1 over xy. Why minus, not plus? Because this the derivative of this is the same as this. So we need the minus here. How to do it in minus? Let's call p2 for x equals x to the power of 2 plus 1 over x to the power of 2. Okay? So that p2 for x equals here x to the power of 2. Instead of plus as we did the previous, the g part, we will do minus 2 x multiplied by 1 over x plus 1 over x squared minus the thing we did, which is just plus 2 to preserve the value of p2 for x. So that p2 for x will be equal to what? So the complete square x plus 1, this time minus, okay? Minus 1 over x all squared plus 2. Alright, let's continue. We have the h will be equal to the integral of 1 plus 1 over x squared, don't forget the dx, over this part, which is x minus 1 over x all squared plus 2. Let's use another substitution. Let z equals x minus 1 over x, so that dz equals the derivative of this is 1 plus 1 over x squared dx, which is the same as this. It's very nice. So that h will be equal to dz over z squared plus 2. Gonna use the inverse tangent method. So let's write this as square root of 2 all squared. Okay. So that h will be equal to 1 over square root of 2 is just square root of 2 over 2. Inverse tangent of z over square root of 2 plus c at the end. This is not the original integral. And the z is the same as this. So we can write it square root of 2 over 2 inverse tangent of this part over square root of 2. So yeah, not this part, this part, sorry. So it's x over square root of 2 minus 1 over square root of 2x. So h will be equal to square root of 2 over 2 inverse tangent multiply the numerator and the denominator of this fraction by x. So we get x squared over square root of 2x, which is the same as the denominator of this. So minus 1. We have I equals 1/2 of g, which is this. So it's square root of 2 over 8. And the ln, when you do the minus for it, the fraction is flipped. So the natural of log of x squared plus square root of 2x plus 1 e over x squared minus square root of 2x plus 1. Here like this. Minus h, minus with minus is plus over 2. So it's the same as this. It's over 2, which is over 4. Inverse tangent of x squared minus 1 over square root of 2x plus c. That's the answer. It's much easier than the previous and the same result. That's the most important thing in this video. We got the same result using an easier method. Next time we'll use complex numbers. It will be the hardest and the longest video, the hardest thing I ever do in my life. Hopefully it will be a nice experience. Sorry for the 4. Yep. Alright, thanks you for watching this video. If any new ideas, any new methods, leave them in the comments below. See ya next time. Thank you for watching. Goodbye.